When Googling for the tool you need, hoping it's a simple statically compiled binary, only to find it as an uncompiled Visual Studio project. No problem, you think. Just download, build, upload to the target, and dependency missing error. This video will cover how to statically compile Visual Studio projects, preventing tools from failing by a missing component. To get started, I'm going to jump into my Windows virtual machine and launch Visual Studio. For the C++ demo, I'm going to go to Close Repository and use the Perfusion from GitHub. Clone. Once it's finished cloning, it'll ask if it can be upgraded. That's completely fine. Hit OK. Before moving forward, I would like to show how to resize your Visual Studio project in case you want to increase the font size, which can be done by going to the top bar Tools, Options, Environment, Fonts and Colors, and then selecting exactly what you want. By default, it's set to the text editor. So if we select our code and go back, Tools, Options, Fonts and Colors, if we set this to like 20, the text will be bigger. Alternatively, at least for the part where you type your code, you can just hold Ctrl and just use your mouse wheel. That does not work for everything else. So if I hover over the output bar and hold Ctrl and scroll, it doesn't work. So Tools, Options. If we want to change the size of the whole window, we would have to go down to the Show Settings for and find the environment. If we're just doing the output window, we go back to Tools, Options, and set it to the output window. I'm going to set those options back, or at least for the environment. With that out of the way, I'm going to move into compiling our code. The first step is to set it to a release, which will change the code generation for this project. What I mean by that is release will just change it to the one that will only work on certain systems that have the required libraries installed. To make it fully static, we need to go to our file, go to Properties, under C++, code generation, and we can see that it's set to multi-threaded MD. If I were to cancel out of this and compile it by right-clicking on the build solution without changing it and leaving it as /MD, grabbing where it got compiled, seeding into this directory, we can see that it's only this big. However, if I go back, right-click on our program, Properties, and I change it from MD to /MT, hit Apply, OK. Now I want to recompile by doing Rebuild Solution. Going back into CMD, we can see that the size has gotten a lot bigger. All the components it needs have been statically compiled. However, setting it to release instead of a debug build might be the only thing you need for something like a C# project. To help demonstrate this, I'm going to compile Rubeus by first cloning the repository. All right, we have Rubeus. Set it to release. Build solution. I will copy Rubeus to as release Rubeus and Defender got in the way. Disable that real quick. Rebuild. There. Now setting it back to debug. Rebuild solution. Now I want to copy debug Rubeus to here as debug Rubeus. All right. The last file I need to test will be another C++ program, which will be a basic reverse shell. I'll just need to change the IP address to what I'm going to use later in the test. It is set to a release. We'll check the code generation. It is set to MD. Build solution. We can see it's this size. If I were to properties, set it to MT, apply, okay, and rebuild solution. We can see it's 10 times bigger. For the sake of time, I've already compiled and moved all the Windows binaries and moved them to the Linux machine using updog. The first demonstration will be with an Active Directory machine running Rubeus and Perfusion to show that even though Perfusion was not statically compiled, it still runs. With all the binaries uploaded to our Active Directory machine, I'm going to start with Perfusion. If I do /perfusion not static, it still runs as normal. If we do the fully compiled Perfusion, it runs just fine. In this case, we can get away with not statically compiling because the Windows machine has what we need on the system already. Double checking with Rubeus. Rubeus.exe, then as rept roast format hashcat output as rep.txt. It's not that because I named it release. The release version works. Let's try the Rubeus debug version. In this case, both compiled C# binaries work. Moving on to the second demo, which will be using a reverse shell on a Windows 7 computer, where the statically compiled binary will run and the other one will fail. For the sake of time, I've already uploaded both reverse shells to our Windows 7 computer. MD test.exe and our statically compiled binary, MT test static.exe. Dropping into a shell and running them one at a time, starting with our MD test.exe, we can see that it attempts to run, but we do not get a reverse shell. However, if we run the empty test static.exe, we get a reverse shell connection. And that concludes this video. Thanks again for watching. All the commands will be in the description below, and I hope to see you on the next one. Take care and have a great day.